question says, a circular race track has a radius of 500 meters and banked at 15 degrees. Calculate the maximum permissible speed to avoid slipping off if A, there's no friction force between the tires and the road, and B, if the coefficient of friction between the tires and the road is 0.3. So we want to find the maximum permissible speed, the speed which must not be surpassed in order to make sure that the car does not slip off. Now, when the speed that we're going to find, if there's no friction, there is a value which the car must be moving so that it does not swerve away or it does not slip or skidding. Then this one here, there is also a value if there is some friction force that is actually opposing the motion of that vehicle. So the value is 0.3, the coefficient of friction. So let us look at something. For part A, let us say this is a road, and then this road is banked at 15 degrees. This is theta. Then there's a vehicle that is actually coming. Let's say, let's put it right here. So let's say the vehicle is here. Then we need to resolve. So let me erase this. Has got a weight. So this is the weight, which is mg. Then there is a normal force right in this direction. So we call it this. Then if we extend this one, here we have theta. So we can, so this one, it is n cos theta. We resolve it in terms of n. We are going to have n cos theta, this one. Then we also have this one, which is the opposite to this angle, which is sine. So we have n sine theta. Then here, okay. Then at the center, since it is in a circular kind, there is centripetal force that is acted towards the center. So towards here, there is, let's say, there is Fc here. So if we resolve this one in terms of x and y axis, or this one, we can say the summation of forces. So from here, we can say the summation of forces. The summation of forces in y must give us a zero when the system is in equilibrium and the forces are balanced. The summation of forces must be equal to 0. So in this direction, we have n cos theta. N cos theta. Then down here we have mg. This must give us 0, so that n cos theta is equal to mg. We can call this equation 1. Then the summation of forces in x. Summation of forces in x must also be equal to 0. In x, we have this one. In this direction, we have n sine theta. N sine theta. Then we have this one, which is the centripetal force, the force towards the center, which is the mv squared over r, the value for Fc, or the formula for Fc is this one. So we have this one. So we have n sine theta is equal to mv squared over r. So let's call this equation 2. So dividing equations 1 into 2, n sine theta over r, then mg here. So this one, okay, let's say mg. But this and this will go, so we're going to have this and this will go. We're going to have b squared over rg. From this point, we know from Sokatoa that sine theta, or from trig ratios, the sine theta over cos theta is tan theta. So this one will be tan theta is equal to b squared over rg. So b squared will be equal to rg tan theta, and v will be equal to the square. And if we plug in the values, if we this one is going to give us 36.2 meters per second. So this is the maximum permissible speed that a vehicle must be moving with in order for it not to slip away from the road. This is the Vmax, the maximum speed if there is no friction between the road and the tires. Then for B, we want to find Vmax if the coefficient of friction is 0.3. So from this, we know that b squared, there's a formula, this is the direct one, b squared is equal to. So after finding, or after resolving everything, we find this expression for B if there is friction force opposing the motion. If we want to find V, it is just a matter of putting everything in square root. So Rg So if we plug in the values, we are going to have so evaluating this and punching on a calculator for the square root here, we are going to have 55 meters per second as Vmax if the coefficient of friction is 0.3, the coefficient of friction between the rod and the tire. Thank you so much for watching the video.